If you are capable to keep that as framework agnostic as possible, it opens up also the possibility in the future to evolve the Micro-Frontends.
Can you explain what an AppShell is?
The idea behind Module Federation is the fact that is a transport layer for bundles.
Can I use different frameworks for different parts of my micro-frontend?
Was trying to figure out how I can explain easily the difference between components and micro-frontends. And the idea is, I think the key here is the extensibility factor.
How is the backend structured to allow access from the front end? You outlined 3 ways: API gateways, BFFs, and service dictionaries. Can you just give us a brief overview of those 3 approaches and where you see them fit?
The fact that you have like an application shell that I think is one key distinction from micro-frontends and other implementation.
Our last topic for the day is the question of feature teams versus component teams.
This episode was made possible thanks to Gotopia.tech.
Hello and welcome to the GOTO Book Club. Today we will talk about building micro-frontends, and I've invited Luca here. Welcome to the show, Luca.
Hi, thank you for having me.
So my name is Dohmen. I'm a senior consultant from innoQ, and I'm also very interested in front ends and how to build good architectures for web applications, especially big ones. But Luca, maybe you can introduce yourself for a second.
Sure. My name is Luca Mezzalira. I'm Italian, but based in London. I'm a principal solution architect in AWS. And in the last 7 years, I explored the micro-frontends topic quite extensively. Not only writing a book, but also building multiple applications and helping customers to implement these architecture pattern across different industries, seeing different challenges and figure out how to overcome them. So it was a very interesting journey so far. So I hope that will continue also for the future.
Awesome. So micro-frontends is already a word where different people have like different ideas what it means, right? But before we get into that, I would say let's first look into the AppShell thing. I think most people are not aware what exactly that means. Can you explain what an AppShell is?
Sure. So the application shell is the first thing in a fat client, as it's called, or rich client-side application that you usually download. So when you type your mysite.com, the first thing that you download in that case is an application shell. Application shell is unaware of the business domain, or it should be as much as possible, because that is a common part. And what is responsible for loading the micro-frontends and routing the URL basically on where the user wants to go, and then load the right micro-frontends associated to that. It's also responsible for deep linking that usually comes comes for free out of the box when we are implementing the application shell, and is usually used either with an horizontal or vertical split. So the application shell, when we do on the client side, we can decide to go with horizontal or vertical or both, as we said before. The interesting part is that the very light implementation. There are several technologies that you can handle that. In my humble opinion, usually if you are capable to keep that as framework agnostic as possible, it opens up also the possibility in the future to evolve the micro-frontends without the coordination of having the application shell that is holding you to experiment or try new things.
So let's dive into that topic as well, because I think one thing that I've come across a lot is the question, can I use different frameworks for different parts of my micro-frontend, or should I use one the same one for everyone, right? Like, should I use Angular and React mixed, and some use an Angular and some are in React, or should I always use React for all of them, right? Not looking at Angular React right now, right? But where do you see both in the vertical and in the horizontal split with AppShell? How do you see how you can handle that?
I think not only despite the architecture pattern that you're going to take on micro-frontends, I would say that is a misconception that was raised by the community for several years by now. And the challenge I see, and usually is this example that I made. So imagine that you have a single page application. Technically speaking, you can mix React and Angular. And I remember back in the days when React came out, there were some experiments on that using the React library as a UI and the rest of Angular framework for the management of the state management and the rest of the application. Now, despite it doesn't mean that you have to. Therefore, in my opinion, there are certain situations where having multiple frameworks might help with micro-frontends. So when you are migrating, for instance, from a legacy application to a new one, or if you are migrating an application from an older version of the framework to a new one, what you want to do instead of going stealth mode for a month and then deliver something in front of your customer is taking a vertical of your application and start to iterate on that, deploying production alongside the previous application, and start to generate value for the users, because we are going back to the real scope why we are developing code. And that's where I can see for a certain period of time, because I know that it's a migration, a mix and match of framework. Otherwise, yes, and another option could be when you are acquiring new companies. So if your company is acquiring another one and you want to immediately see the value that of your investment inside your let's say brand, inside your umbrella, you can do that, and you can easily have another, let's say, technology that is developed by the other company that is living alongside your application. That is another situation. Overall, I discourage this practice unless there are strong, let's say, reasoning behind that, because obviously it's going to have an impact on your users. And at the end of the day, we know that for certain type of workloads, think about, for instance, e-commerce, the first time byte is quite important because it could, let's say, generate more revenue or not. And I know that sometimes it could seem silly what I'm saying, that 1 second could generate millions in revenue. But in reality, we have quite a lot of companies that prove that is true. And therefore, it's very important that we optimize our application despite the architecture that we're using without penalizing our customers.
Yeah, even though I agree, we should not go to a multi-framework solution, right? Because we are downloading way too much data, and it will also be complicated for things like server-side pre-rendering and stuff like that. I think that a lot of people that are doing architectures for the front end are paying not enough attention to the fact that you already mentioned of migrations, right? If we are going into a situation where we need to do a framework update that is a breaking change, for example, and we are forced to do it across our entire application, then we are paying all the costs that we have for a monolith, right? Because then we need to update all at once, and that might be costly. And the same goes for, if you remember something like Backbone.js, that was the first framework I built a single page application with. Nobody would use it today, I would say, right? And sometimes those frameworks go out of style, and we cannot say which one will maybe be end of life by the people behind it, right? It's not very likely that React and Angular will just disappear, right? Because there are so many applications written in it, but we should at least keep it in the back of our minds that this might happen, and that we have a strategy if that occurs, and especially for the framework updates, the breaking changes will be something you should pay attention to, in my opinion.
Yeah, I fully agree. Also because often we need to think about if technically architects and developers are more keen to work with modularity, the business instead wants to work with agility. So they want to drift the direction in the way that they want. And if we link agility with modularity, basically you have exactly what we are talking about here. So you have the possibility to take the drift of the organization towards your architecture and therefore your code, and shift the way how you are working today for having a better future tomorrow. That is, let's say, probably the key thing that an architect should do, trying to map the business characteristics towards what we are trying to build. But yeah, I agree with you in your mindset and approach.
So one other integration method, so AppShell would be one integration method, right? One other thing you brought up on the client side horizontal split was module federation, which is a feature from Webpack. Can you explain what what that does on a high level, right? Not on a code level, because that's always a bit bad on a format like this one. What it means and what it does.
Yeah, sure. So Module Federation is an official Webpack plugin that is available from Webpack 5. The interesting part that it does is not mainly for Micro-Frontends. The idea behind Module Federation is the fact that it's a transport layer for bundles. And that opens up quite a lot of opportunities, not only on the client side, but also if you think about cloud or server side, you can still use Module Federation, no problem. The interesting bit for Micro-Frontends is that if I talk about a transport layer for bundles, bundles could be an independent piece of code, and therefore it resigns very well with the concept of Micro-Frontends. And that means potentially I can use Module Federation for composing my Micro-Frontends, because what it does is exactly this. I take a bundle that is independent and I load inside another application. That is exactly what we want to do with Micro-Frontends. The other great thing that Module Federation does is taking care about the dependencies. Because one of the challenges you have when you deal with your own implementation of Micro-Frontends is how I can make sure that everyone is using React 15 or React 16 or the same version of a framework or library, whatever. Module Federation abstracts that for you, but goes even, further, providing you the possibility to, create a scope around the same library with different versions. So if a team wants to use, Moment.js with an older version compared to the rest of the application, they can do that without clashing because the scope is different. And that is another great functionality of Module Federation. I think the interesting bit is very foundational. Is going to a level where, yes, you are tied with Webpack 5. There is a version for Webpack 4 that doesn't have the full-fledged features that I described. There is another one on ESPL that I know that is about to be built or in progress. And there are other open source frameworks that are doing something similar without using Webpack. But the overall idea of creating a way that abstract the loading of a specific module, of specific bundle, is pretty good. Because the other thing we often forgot to say about Module Federation is because it's a Webpack plugin, we can mix and match with the rest of the plugins available in the ecosystem. Therefore, if Module Federation generates too many chunks of your JavaScript, you can configure it in a way that instead you have just, one chunk or smaller chunk, or you want to set a certain budget per chunk. Every chunk has to be at least 15 kilobytes, stuff like that. So you have a great flexibility and is solving a quite peculiar problem of Micro-Frontends.
But does it mean that the build of those different subsystems or different micro-frontends are bound to each other, or are they still independently buildable? So can I just build the component that does the product view, for example, or is that not possible anymore?
It's totally possible because the whole point of Module Federation is moving away from the concept I need to centralize the build of my elements. I can use Module Federation. There are two concepts that are key: the host, that is the container of another bundle, and the remote, that is what is loaded inside the host. The beauty of this approach is that you can create multiple applications completely independent that are living inside their own world, and then load them together at runtime. And all the loading part is handled by Module Federation. So you just need to deploy, for instance, let's assume that you're using an S3 bucket with a CloudFront distribution in front of it. You deploy your Micro-Frontend tens of times per day in S3, and every time that application shell is loading, with Module Federation, is going to load the latest version of your Micro-Frontend. The beauty of this is you're completely independent, despite you're using Webpack, that I know sometimes we think always, we centralize everything with Webpack.
Mm-hmm. Okay, but all we need to align on is the build tool that we are using, right? So we are bound to the same version of Webpack for all Micro-Frontends,
Webpack
right?
5, yeah, correct.
Yes, okay. But not Webpack 5.110 or something, right?
No, it's just Webpack 5.
Okay,
It should be
cool.
retro-compatible. I didn't try that, but I never, to be honest, I never heard anything like that.
Okay, cool. Okay, so a second approach that you outline in the book is using iFrames for a horizontal split. So I think a lot of people, when they hear iFrames, they think this is like an outdated technology that nobody uses today. What's your take on that?
I agree in certain contexts. In others, it's solving quite a few problems. So iFrames, yes, are true or not new, but are the safest option that we have for create strong boundaries for our and have a bit of control for our code. So if, for instance, you acquire a company and the code that maybe is an old jQuery with other things that you want to put inside your brand new Micro-Frontends application, but you don't want to have the headache to go through the code and build or anything, you take the build that is available currently in the application, you move in your server, and you use an iframe to basically protect the rest of your application. That is a nice way. There is a Micro-Frontends framework called Luigi framework that was created by SAP that is using iframes for isolating the different contexts. And usually what they do is using this iframe, that there are not many per view, there are 3 or 4, and they're using that because they are sure that who is developing the code is not going to clash with the rest. And they provide a set of facilities in this Luigi framework for communication part, retrieving the authentication on SAP and stuff like that. The other option that I have seen iframes very useful is on the security side. Because there are certain, industries that require a strong set of securities, and with iframe, you can fulfill them very easily. And therefore, I agree there are several drawbacks on iframe that are quite heavy and so on and so forth, but there are situations where iframes can be a valuable option. The other thing is currently the TC39 is exploring a proposal that's called Shadow Realms. They changed the name recently. And the idea is basically having a glorified iframe, but without all the burden and the problems that we have with the iframe. So you don't have to have the full structure of the window, the object, and so on, but you have like a light iframe with all the benefits of create boundaries around your code.
Yeah, so I've never seen anyone use iframes to integrate within one company, right? But I think especially using it between companies, if you are integrating something from a different company, then iframes are a very good solution. I think a good example for that is Google Maps. That everyone uses iframes to integrate Google Maps, right? They don't realize it because they put in a script source, but it's a good way to really, for security reasons, split out this application and don't give it access to the entire DOM that you have, right? But I would say it's a rather unintuitive way to integrate within your company where you have higher levels of trust, I would say.
Yes, it's true. But very often in large organizations, I have seen used iframes, despite there are nowadays other options for security reasons.
So one other thing are web components, and I think this is also one of those words where people are not entirely sure what it means. So can you explain what the pillars of web components are?
Yeah, web components are an API standard that is available for developers to create components that are compatible with nowadays vast majority all the browsers, if not vast majority of them, and is providing some utilities like custom components and shadow DOM. And those two things are quite key for Micro-Frontends. So the custom component is possibility to create your own component that contains your code. And the interesting bit you can have in light DOM or in shadow DOM, depends which path you're going to take. And the main difference is the shadow DOM basically is completely decoupled from the main DOM element. And that means basically that you can, for instance, have also some duplication on classic example, CSS style. They are not going to override the one that are available or be overridden by the one of the application, what the application is using. Because the shadow DOM is basically like a nice black box that is preventing that someone can access it. I think the interesting part of web components is that nowadays, if you're using them, you are compatible with any framework. So if you are doing an effort for building some elements with web components, then you know that if today's React and tomorrow will be Vue.js, you will be able to reuse that part of the code. That is great. In fact, I also in my book, I warmly recommend them if it's possible to use them for creating design systems, because that basically will allow you to reuse portion of your code and your application, despite the underlying UI framework could change. And that, for me, in my head, creates also this concept of evolutionary architecture that web components can provide. The only challenge I have seen so far with web components for Micro-Frontends is that often developers are overlapping this concept of components and Micro-Frontend. And that is a risk, because sometimes you might hear people say, oh, yes, we are using Micro-Frontends and we have a gazillion of Micro-Frontends in the same view, but in reality, they're using components. And a rule of thumb that I try to rationalize lately, probably was towards the end of the book, was trying to figure out how I can explain easily the difference between components and Micro-Frontends. And the idea is, I think the key here is the extensibility factor. If you think about the component, usually the container is providing some context for the component to behave. In that case, you pass maybe, I don't know, the labels, the localization, the type of behavior you expect from the component, and so on and so forth. In the Micro-Frontend, you define the input and output. Worst case scenario, you can inject an event emitter, or let's say something that's very, not domain related, but the Micro-Frontend's own is narrative. He knows how to build, he knows how to render, he knows everything that how to behave, but it doesn't have to be instruct from the container. Therefore, there is no leak of domain outside the Micro-Frontend. And that is, for me, the key difference to understand if we're dealing with components on Micro-Frontends.
Yeah, but you already mentioned the problem with CSS, right? So if I take the solution with client-side approach with an AppShell, then I might have collisions in CSS class names, for example. So one approach would be to use Shadow DOM, as you already outlined. Are there any other approaches that we can use for getting out of trouble there?
Yeah, and another idea that is, let's say, quite simple to implement, despite you're using web components or not, is using prefix. So if you divide the work that you're doing in multiple teams, every team might have a name or a domain that are representing. So if they prepend the style, the class name that they want to use with their own unique name, they can then have a uniqueness on their class name. So there isn't the risk that there will be a clash. And that is usually one thing. For instance, I was using Material UI for a demo and for using Micro-Frontends, and I have to make sure that they didn't clash together, because it was Material UI across the entire application, but with different parameter and everything. So I don't want that the same style or class name that was rendering one way in one part of the application could clash with another one. Therefore, in that case, using prefixes, I was able to decouple basically the two styles. And despite I might have two styles that by default would clash together in the application shell, they weren't clashing in reality, because there was a prefix that was, let's say, creating uniqueness on those styles.
So one thing I wondered when I read the book, and also I wondered again now, is how do you handle things like pattern libraries? So if I want to do something like a shared style between all the applications, right? They have like certain amount of code, a certain amount of styling that is shared between everyone, and a certain amount that is like very specific to one part of the application, right? So how do you handle that both in Shadow DOM and in something like BEM that you just mentioned? How do you do that?
So usually in Shadow DOM, you have less problems because are encapsulated. So in that case, you can take your own decisions, and every component that won't clash with each other because it's not even in the same if you want, scope of the application. In the other side, I think with BAM is the prefixes that allows you. BAM basically provide you a more granular way to describe the element that you are styling, and going more up to a certain granularity that makes more difficult to have, let's say, redundancy on names. But if that happens, the prefix strategy, it helps a lot, because then at the end of the day, if you're using the same button but with different, let's say, styles or parameter that you want to use, you can do that without any clash, because you are going to basically create, let's say, your way to handle one thing, and then you can supplement, as you described before, with your own style for that specific portion of the application that require different styles. So you can really do mix and match with just this simple implementation.
So maybe this is a bit too deep into the technical part, but if I imagine that you have a page that consists of the AppShell and then three sub parts that are that are split, right? That are different parts of the application, and each of them has its own shadow DOM. So, do you include like the basic styling as one CSS file in each of the shadow DOMs and the AppShell, and then add specific styling to the subparts, or how do you do that in practice?
Usually, so if you go in the path that you include all the base element, obviously it's going to let's say have more kilobytes to download for the users, but you guarantee that are completely independent. So potentially, if tomorrow one of the team is using an older version of the styles, that you will still provide, let's say, an independent element that can be updated at some point. The moment that you start to share anything, style, code, whatever, across those three independent parts, then you have a risk that there is a runtime error that you didn't pick up in your environment or in dev environment, because it potentially could be different. So ideally, you need to understand if that is the, let's say, trade-off that you want to take, or if you create more, you spend more energy and more effort for making sure that everything is loaded at runtime is not going to blow up in front of the customer. Mm-hmm. Okay. It's up to you to decide where you want to spend your effort. It could be as simple as say, okay, I have a bit of duplication. It's 10 kilobyte more. It's not the end of the world. Or no, that 10 kilobyte, I really need them. And therefore, I need to find a way to optimize my pipeline to make sure that I'm not going to create issues at runtime.
So one thing that we did in one project was that the base style was available versioned at a URL, and you could use it in the different parts of the application. And then you can take advantage of caching, right? So at least if everyone is on the same version at that point in time, you only download it once, right? But that's also an approach where you can maybe find like a middle ground between those two approaches.
Oh yeah, of course.
So talking about the server-side part, I think one of the things that a lot of people have never heard about is SSI and ESI, and maybe some people heard about SSI like a lot of years ago. Can you first explain what ESI and SSI are?
Yeah, so SSI and ESI are server-side include and edge-side include. Those are a markup language that basically are using a mechanism called transclusion. Transclusion basically is an algorithm. What it does is very simple. You have a placeholder element that when is parsed by the engine is going to be replaced by more concrete elements. That, for instance, imagine that you have, a cart element that you are describing with that placeholder, and then when the engine is going to parse that markup element, is going to replace that with a div element and maybe an image that represent the icon and some links. So that is basically what it means. Those are running either edge side include on the CDN level or server side include on the server level. And I think server-side include is a quite old technology. So it's nothing revolutionary, but allows you to work at the server side and compose multiple elements, because there are servers like Nginx, for instance, that are allowing you to use this technique for composing your page and provide a final output for the user. On the edge side include instead is a markup language that was created back back in the days by Akamai and Oracle and a few other companies that is available in certain CDNs providers, and not all of them. And the other problem is the one that are supporting ESI sometimes are not even supporting the full implementation. Therefore, if you think about a multi-CDN strategy, probably is not feasible. Or if you are thinking to migrate from one CDN that has the full fledged of specification implemented to another one, you might think twice because you don't know if everything is supported. The other problem of ESI more than SSI is the developer experience that I think is quite important. In ESI, there aren't many companies that are providing a smooth developer experience, so you need to test with against your CDN. Akamai, for instance, is providing a Docker container that basically allows you to test on your laptop how the CDN node in Akamai would render your application, but it's the only company currently that I am aware that is doing something like that. Usually these techniques I have seen used where you have, let's say, more static content on the UI. So for instance, IKEA used edge side include back in the days for their catalog, and everything was extremely static. They were using edge side include, and when they started to have dynamicity, or they wanted dynamic content or interactivity, they supplement edge side include with client side include. There are some libraries available in JavaScript that basically they do exactly the same thing using transcription, but on the client side. So you can mix and match those and provide interactivity as well, high cacheability and also let's say span the load across multiple edge nodes instead of going every time to the origin, that usually the origin are way less than all the CDN nodes that are available in any cloud provider.
Very cool. So one thing I noticed when I read the book is that one approach that we at innoQ use a lot that is very focused on vertical splits is not really described in the book. So I wanted to get your opinion where you fit it into your frame of mind, right? So I added it to this as well. So a few years ago, we wrote this guideline called Self-Contained Systems, where we describe how you can integrate multiple vertical splits into one system, right? And there we focused a lot on server-side routing or edge-side routing. I don't make a big distinction between those two.
Yeah.
Each of those systems delivers its own front end, right? So it's entire stack from database to front end, right? And we integrate those systems with things that we already mentioned, like transclusions or also components in the other system, both transclusions on with ESI or also client-side transclusions that you just mentioned, and also simple things like links between those two systems, right? So they are really independently, deployable, right? They are manageable by one team. Where would you put that into your frame of reference?
But in that case, I would say, are we in front of Micro-Frontends? Because the reality is, yes, you divide by system, but if we say that everything that is divided by multiple systems that are rendered on the client side might represent Micro-Frontend, then where is the distinction between a single page application or Micro-Frontends or whatever it is? So I think the distinction on Micro-Frontends is the fact that you have a map with the business domain, and then you can go more granular or whatever. The fact that and you have like an application shell that I think is one key distinction from Micro-Frontends and other implementation. In your case, you are dividing more in a modular monolith fashion, where you divide some verticals that might or not represent a domain, and then you are basically linking and using web standards for moving between the two. I think not even sure that I would categorize as Micro-Frontends.
That's good to know, because I just wanted to understand where you see the distinction, because in the past I saw descriptions of Micro-Frontends where this would be part of it and other parts where this would not be part of it, right? So it's always good to like get a good frame of reference because it's a different approach to it that solves some of the same problems because you still can deploy independently and so on. But goes a different route. Okay, so that's good to know. That's helped me a lot. One thing that you also described in your book is the whole topic of the backend structure. So how is the backend structured to allow access from the front end? And you outlined 3 ways: API gateways, BFFs, and service dictionaries. Can you just give us a brief overview of those 3 approaches and where you see them fit?
Sure. I will start with the service dictionary that probably is nothing new, but I think is very helpful. So a way that I found helpful to decouple Micro-Frontends from the endpoints that allow basically to run independently the backend parts with the front-end part is injecting basically to the Micro-Frontends the list of endpoints to use with a dictionary basically of services that are available. That allows basically to a Micro-Frontend to pick the service that they need, and also potentially you can do something even smarter. And every time the Micro-Frontend is requesting a specific service dictionary, you serve a list of endpoints that are useful for that version of the Micro-Frontends. That allows, for instance, if you work with API control first, where you maintain the same code and the same contract between the API, then you can evolve independently the application. You don't even have to care about injecting them in CI/CD as I have seen before, or even create a library that is loaded inside the Micro-Frontends for handling this part. Because when you have these kind of information that are loaded, you might risk that you, instead of having all the Micro-Frontends using a specific version of the APIs, you have certain Micro-Frontends that are using a version, some others another version, and then you need to coordinate the redeployment of this shared library that is a pain, especially in large organizations. So this one is just a runtime way for handling that. Is as simple as a JSON schema or a JSON that is providing a list of endpoints that are specific for a Micro-Frontend. In the case of API gateway, API gateway is well-known way for exposing APIs especially in microservices world, and in that case, you have like your endpoint that are you can, let's say, have behind an API gateway wherever you want, portion of monolith and the rest microservices. All microservices completely up to you, but for the client, it's not a big deal, and that basically also might help where people are saying, oh, if we work with microservices and Micro-Frontend, we need to have cross-functional teams. It's not true, because you can, at the end of the day, you can use APIs as a nice way for communicating between teams, front end and back end, and maintain the independence of these 2 layers. Then there are people that argue, but I want to have some work that is handled by one team only, can deliver a feature independently and create, let's say, value for the customers. And I agree, that is the favorite way also for me. But there are certain situations like you cannot do that. For instance, in my previous company, we had roughly 40 different targets on the front end that we need to manage, and with different technologies. So if I have to create a team that can deliver a feature end to end without creating first-class citizenship inside my teams, I need to have a team of 15, 20 people. That is not manageable at all. It doesn't perform. So instead, if we divide, in that case, in front end and back end, you can have, let's say, more interaction between front end and back end teams. But at the end, if you work well with API contract first, you reduce basically this type of interaction that can work independently against the same API contract that is not changing every day. And the last one is backend for frontend, where backend for frontend basically is a pattern that allows you to, usually a frontend team, to create a layer that is in between the APIs and the frontend, and they are able to use the APIs that they want, put them together, and serve to their client. Usually are divided by device. So you have like maybe a mobile backend for front end, one web, etc. But I have seen also people that are dividing per domain. So instead of having one per device, you have like one for, I don't know, the catalog and one for authentication. And you handle that in that way. It really depends how you want to, how complex is the application, how large is the application, how you are structured. But backend for frontend provides a benefit where also, if someone is updating, let's say, an API, and you're not aware for that for any given reason, it's not going to cause a cascade effect on the client side. So you can slowly but steady migrate your API on the backend for front-end layer, and also aggregate them in a way that the client can do less round trips and provide a better experience for the users. And sometimes I have seen use REST, sometimes I've seen use GraphQL for this implementation. It's completely up to the team. And often I have also seen one backend for frontend written with GraphQL and use schema federation for stitching together the different APIs in a unique layer that the clients can consume, either mobile, web, Micro-Frontends, or monolithic application.
Where do you see the responsibility for the BFF? Is it the responsibility of the front-end team that uses it, or is it the responsibility of a different team?
For me, it would be responsibility of the front-end team, because they are the ones that are using that layer and consuming that layer. So they need to know how to handle that. However, I would recommend to have some help from the backend teams, because there are certain, let's say, topics like scalability, observability, stuff like that they have definitely more experience, especially when we are talking about building microservices.
Very cool. So one thing you already brought up, but I wanted to have as our last topic for the day is the question of feature teams versus component teams. So how do you see team structure, and where do you see it in regards to all the things that we talked about until this point?
I don't have a strong preference. I mean, I work in both, and I've seen both systems working. I think that the context should drive that decision. As I said before, I had, so let's say, the possibility to work in companies where it was impossible to work with features team, and others that I work in feature teams, and it was working extremely well. The problem there then is when you have a limited amount of resource, but the number of features are growing. And then you have a feature team that suddenly it becomes a features team. And therefore, you have to handle multiple of them that are touching multiple points, and the complexity start to raise. For me, it's very important as a tech leadership in general, architects, principal engineers, whatever, that we take regular steps back to understand if our model is still valid. Because often companies start with one way and they stick with that, despite it's not working. And then the problem is, but we don't have enough developers, so we don't hire the right developers. And in reality, maybe the problem is only how the communication structure works, how the company is organized. So either that you pick component or feature team, my suggestion is check regularly if that is a model that is still working for your company, or if the way how you slice your domains is correct. Because as the company is evolving, your architecture has to evolve with the company. It's not something static. It's completely fluid and organic. We need to bear in mind that with the moment that we are designing an application today, in 1 year time, the things could be completely different with the same people or not, because the business drift in towards a different direction from the beginning. And so the assumption and the characteristics of our architecture and the organization structure that we made a year ago are now obsolete, and we need to replace them with another way. So don't be afraid to change and switch model if you see that there are some challenges, and question yourself. It might be that it creates a genuine discussion, but questioning the decision that we were making like 6 months ago, 4 months usually is a good time, but 12 months ago is definitely one thing that I encourage any company to do.
I think those are very good closing words, because I think it's very true for a lot of parts of our system that we should question our decisions, and also think about which architecture really fits our needs, and maybe at the beginning where we are more flexible of changing things, especially change things up when we notice that it doesn't fit us, even though we thought that it would. So thank you so much, Luca, for your time and for your insights. And I wish you a nice day, and all our listeners the same.
Thank you very much for having me, and it was a pleasure sharing with you my perception of Micro-Frontends. I hope that you will enjoy the book, and thank you again for having me.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.